Scatter plots and correlations are tools that we can use to help us understand the relationship or connection, if any, between two different data sets. So something to keep in mind is that everything we're going to be looking at in this section requires that we have two data sets available and that those are paired data sets, meaning the values in the first data set have some connection with the values in the second data set. So scatter plots allow us to graph paired data. We'll talk a little bit more about that when we see our first data set on the same coordinate plane. One variable is represented as the values along the x-axis, while the other is represented as the values along the y-axis. And what scatter plots help us do is understand the association, if any, between those two variables by looking at the trend, the shape, and the strength of a possible association. We have a few different graphs pictured here. Keeping in mind our horizontal axis is the x-axis, our vertical axis represents the y-axis, and what we want to do is discuss those three different concepts: trend, shape, and strength. For this first graph, if we were to picture sort of a straight line drawn through these points, kind of approximating the pattern and direction that those points are headed, what we can see is that we have an increasing trend because as we look at that graph from left to right, the points are increasing, the y values are getting larger. Our shape is more or less linear because those points, while they don't follow a perfect straight line pattern, are somewhat closely approximating a straight line pattern. And the strength, in this case we would say, is strong because the points are hugging pretty tightly to that straight line that we're sort of imagining running through the middle of them. We could do the same thing with the second graph. Again, picture or draw that straight line pattern through those points. We still see an increasing trend. We still see a mostly linear pattern. But in this case, the strength of this relationship we could classify as something more like moderate. The points are still roughly following that straight line pattern, but they're not hugging as tight to that line that we're drawing or imagining passing through them. In the third graph, we would just call this a case of no association. These points aren't really following any clear pattern, they're just scattered and sort of random. There's no straight line pattern, they're not clearly increasing or decreasing. Looking at the next one, if we draw that straight line, kind of approximating the pattern that they're following, we see that we have a decreasing trend because the points, the y values are decreasing as we move from left to right. That pattern is still linear, and we could describe this association strength as, again, being moderate, since there's a little bit of scatter, a little bit more distance between those points from time to time. With our next graph, we see something that is, again, decreasing and linear, but we have a much stronger level of strength, a much tighter pattern to that straight line that we're approximating or visualizing. In our last graph that we've got pictured here, this can be a little bit harder to see, but if we follow this around, we can see that this trend is actually decreasing and then changing again to increasing. That shape is something that we refer to that trend as changing, because it's not strictly increasing or decreasing. And the shape, in this case, isn't linear, but a parabola. So a curve that changes from increasing to decreasing, or vice versa. And our strength, we could say again here, is moderate because our points are generally following that pattern, but there's a little bit of spread. Some points get a little further away. So in that last example, what we have is a case of changing trend. Meaning that it's not simply increasing or decreasing. And that's a real pattern that we can see with real data. But for our purposes, we're going to focus on cases where we see pretty strictly increasing, decreasing, or in this case, data sets with no association. In example 1, we want to take a look at a case of how we construct a scatter plot in Desmos. In this case, what we have is the data on the number of roller coasters in a given country and the amount that that country has contributed to tsunami aid. So, two variables that don't really have a lot of obvious connection with each other, but these are paired data sets to refer back to that idea from before, because the value in the first column and the value in the second column are paired in the sense that they come from that same country. So the 7 and the 139 have a paired connection since they're sourced from the same place. To construct this scatter plot, we'll go to Desmos and using that plus icon, create a table, and then we'll just type in these data values. We'll let X equal our value for roller coasters and Y equal the value for tsunami aid. Since these are paired data sets, it's going to be important that we keep those pairs connected. So the two values for the same country have to be across from each other. Once we have that data entered, we can click on this little plus magnifying glass to zoom fit and see our data. Then we can apply that same language that we used for those previous graphs to talk about trend, shape, and strength of this more real-world data. In this case, what we can see is we have a fairly strong positive linear association since our points are following a mostly straight line pattern and the Y values are increasing as we read the graph from left to right. So seeing that increasing positive linear trend would tell us that countries with more roller coasters tend to contribute more to tsunami aid. Because again, as our X values increase, meaning that country has more roller coasters, we're also seeing an increase in the Y value, so that value is contributing more to tsunami aid.